All right, let's do it. Hope you're doing well today. Here's another rendition of Zephyr 101. I'm Jared, and let's jump into it. Today we're going to be talking about doing programming displays using LVGL in Zephyr. Some of you are already familiar with LVGL, so this should be pretty straightforward. It's just connecting the dots between kind of the Zephyr subsystem configuration, overlays, and things like that, and turning it around and turning it into something useful for your application. So if you haven't already, hit that subscribe button, hit that like button, give me some feedback, shoot me a message or leave a message down below. Let me know what things you'd like to see covered on the Zephyr 101 show, these live streams. I'd love to cover it. A lot of the inspiration comes from the community, so it's great to hear from you. Also, something cool that's happening this week is we're doing a little promotion. So 10% off if you use the code FALL10 at my store. It's in the description box below, both the code and the link to the store. So if you missed out on the last time we had a little sale, now's the time if you want to pick up some NRF 9160 feathers. I'm also very excited working on another board. So it's not going to be crazy, but I think it's going to be cool. It's going to help anybody who wants to add Bluetooth to their NRF 9160 feather based projects. It's going to make it really easy. So, but that'll be coming soon. So stay tuned. On to the fun stuff. So you can use displays using LVGL on Zephyr. They actually, right below their website there, they actually have a whole list of RTOSs that support it, and of course Zephyr is on the list. We'll be using in particular, so you can use display drivers in Zephyr. There are a bunch of them, but in particular we're going to be using the SSD 1306 with some extra flags turned on for supporting the particular driver that we're using with the Adafruit board that we're going to be playing with. Here's a picture of the setup. This is actually sitting in my kitchen right now. It's an air quality setup. It's using Adafruit by one of those bicolor OLEDs, 64 by 128 pixels, and it's taking data from the air quality wing designed by yours truly, and we're getting temperature, humidity, PM 2.5, technically PM 10, it's essentially the same thing, through the sensor, and then also VOCs. So it kind of covers the spectrum of things you would care about in the air. So, but all that data is being displayed on that OLED, and we'll jump into actually kind of getting that running. It was pretty straightforward. I was fortunate. I think in Zephyr there are some samples where you can kind of go and check them out and figure out how to use LVGL, but it took me a hot minute to kind of figure it out. So got some tea on board here. So first thing is just making sure that you have the display subsystem turned on, and we are using the SSD 1306 driver. Now if you go over to Adafruit's website, you'll notice that if you go to the page for this particular part, they're like, oh, this isn't an SSD 1306, this is an SH1107. And the cool thing is this particular driver does have a compatibility layer for the SH1106, so I took a gamble to see if it would work with the SH1107, and it worked fantastically. So one other thing you might want to do is by default, I believe the screen is reversed or inverted or one of the two, and that's one of the flags here is that reverse mode, just making sure it's in the correct orientation, the correct setting. Here are the prj.conf. We'll go into kind of the details of some of these guys, but here are kind of the minimal ones that are used to at least get some text on the screen, and we'll go kind of one by one. But the main one here is make sure that you got config_LVGL enabled. Kind of important. One thing that I noticed is I was getting some problems just getting things to show up, or things to show up correctly, or they're in the wrong orientation. So one thing you just got to make sure is you have some of the correct settings. That's one thing about kind of LGVL and Zephyr is that there are some settings in the overlay, but there's also some settings you might have to tweak in your kconfig and your project configuration. So a little bit of both. In this case,
just making sure some of the defaults, like the bits per pixel, I think was defaulted to something else like 2 or 4 or 8. I'm not exactly sure. But because this is a binary 1 and 0 OLED, we want to make sure there's just 1 bit per pixel. The color depth, we're just setting it to, again, 1. We're just got a binary. The dots per inch is set to what the display is set to. So that's one other thing you're just going to make sure. And one thing I've been playing with is just the different fonts, and I'll go into that in a second. And then also memory pool, and we'll go into that in more detail. So there are a bunch of different widgets and things that you can get going with LVGL. One of those things is a label, and the label is kind of like the basic text placement on your kind of canvas. And of course, we're using the canvas. So canvas allows you to kind of indicate a position you'd like to place something, and that's kind of the XY position that it lives in for the duration or for however long you want it to be there. So these are the kind of the minimum level of functionality from LVGL that we need to have enabled to get that to work. And also, like I mentioned, dot per inch, we just got to make sure it's set correctly. The display density is important because you don't want it to be wrong. Otherwise, it'll just show a bunch of garbage. So again, going to the depth, the pixel depth, and then the color depth. It's just all the things that you got to make sure is synced up with your display. If you have a color display, it's obviously going to be different for your. And I would just take a look at the Kconfig and see what it looks like there, and then you can either change it or leave the default depending on your situation. I found that this monoserif font, this 12 pixel high font, was most useful. It was the best looking one for this particular application. If you actually go back to, this is actually using that 12 pixel. The other one was kind of blocky and smaller, and it just didn't really work. So this actually looked pretty nice, and it was just enough to, you can glance at it across the room and you wouldn't really have to squint or try to figure out what it said. You can pretty much see it. But there are a bunch of different other fonts in there. You can check out the Kconfig in the LVGL module. So that's the full path. If you have everything pulled out into on your machine, you can go check out that Kconfig, and that'll give you a bunch of LGVL Kconfig variables, but also it'll give you all the different fonts that you might be able to choose. And worst case, you could always import it or something like that, but we won't go into anything crazy like that today. Another thing is you got the mempool and the number of blocks. So these are just kind of blocks of memory, of heap space that you can use to kind of store display information. I think I had it set to 8, but this is all depending on your application. So some applications need a little bit more intense amount of memory. Some of them don't. So this is kind of a thing I would allude to or compare with it to setting the stack size for a function or for a thread in Zephyr. Is like you set it, you figure out, okay, I probably need about this amount, enough of this stack space, but let's try it. Let's look at the stack monitor and see how much I have and how much I'm using, and do I need to add more or less. Same kind of thing here. If you're getting some asserts, runtime assertions or anything like that, then you might have to tweak this depending on your situation. So if you are memory constrained, then you have to kind of figure this out as you go, and you got to tweak it as need be. But that was kind of the default that I had used or found that worked for me. On the overlay side, here is setting the display. So of course, Zephyr comma display, and we are setting that to a display, and that is, of course, we're setting the display in the I2C device here. So nothing crazy here. I'll go into some of that in a second. So in some cases, if you are streaming lots of data, the buffer for the I2C is somewhat small. You might get some errors or problems. So I found that this concat buff size actually is fairly useful for improving the I2C performance. I think what was happening was I was configuring the device and it was only partially working, or it wasn't responding correctly. So this was a shot in the dark, and it actually fixed it. So I think I actually ended up looking at it on the CLE, and I saw, oh wow, okay, I'm like dropping data, or the amount of data wasn't coming over correctly. So, but that fixed it there. And then depending on how often you're writing to the screen, or how intensive your application might be with the display, you might have to increase the bitrate. I'm using the default one, which is 100K. Most devices either support 100K or 400K. If there's you might have a peripheral that's able to support faster. I know on the Nordic chips they do not, but you might have something else, another chip somewhere in the Zephyr ecosystem that does. So you just got to play with it, make sure that both the display and your host chip there is able to support something faster. We're going into this. So this is within that I2C device. We are declaring the display. We're setting it compatible to the DTS binding that is referring to for this particular device. The more important things here are just making sure that your width and height match your display. And while we saw that earlier, the board uses the SH1107. There's compatibility, but that is done in the kconfig rather than in the device tree. So it's just like something you have to look at. My biggest suggestion is, like, people always ask me, it's like, hey, how do I figure out this particular driver or whatever? It's like, sadly, like, there is some documentation somewhere in the docs. So it's usually pretty light. It's not going to walk you through the steps on how to do it exactly. So sometimes you actually have to look into the DTS binding. And for instance, the DTS binding here, if you go to that Zephyr DTS bindings display Solomon SSD 1306, there are some descriptions in there, so it will provide you at least like what these entries actually do. But it's also a matter of looking at the kconfig, and it's a matter of looking at everything else that's involved with the driver, looking at the driver file, looking at how the usually there's some type of sample in Zephyr that you can look at to see what's going on. So those are just some tidbits and tips that you should be able to take here and kind of go and figure out if you have a particular driver that you're having trouble with. So here are some. So here we're going to jump into the code real quick. So this provides you an interface for kind of providing a pointer for all the things that you're drawing on the screen, so that way you can go back and use them later on. So I created labels for both the label, which is like indicating like what this is, like temperature, humidity, blah, and then also creating a quote-unquote label for the actual temperature value, the humidity value, so on and so forth. And these are keeping them static. We're keeping them in the main file, and we're just using them to reference them later on in the code. This should look fairly familiar for everybody at this point. If you're new to the channel, you will get to know device DT get. It's a thing. So the thing here is that we're using the DT chosen. So if you go back and look at that original overlay, I'm using the chosen, and I'm setting the Zephyr display. So we're just calling out that particular device in there. That way you can have multiple, say you have, we have a display, we're pulling it. This is just kind of like the generic display. So maybe you have another board that has a similar display, but it might have some different underlying driver configuration or anything like that. You can actually you don't have to change the code here, but it's all kind of changing your overlay and then your board specific configuration. So that is the power of Zephyr. It is awesome. You just got to make sure that you're able to kind of split out the parts that belong to each specific board configuration you have. Here we are. So this is a one-time thing. You got to create a label. So we're creating the label, and then we're setting the default text for it. And then we're setting it the alignment, and then also just kind of the position on the screen. And then we're also doing that for the actual value. So we're creating it, setting the default text first. So before it gets the measurement, I just put a little star in there. And then we're also just kind of setting a default position. We're aligning it to the top left. The height of the text is 12, so I just gave it a couple pixels away from each other, so that way they're not overwriting each other. And this LV task handler essentially just does the redrawing every time you make a change. So depending on your application, you might want to call this every time you make a specific change in a specific area of the screen. Sometimes you might want to make a bunch of changes and then sync it. It really depends on your application. So we've created labels to store the text, the kind of the label text, but also the data. We can update them using the set text, and we can draw it with the LV task handler and repeat as is necessary. And then also the create label, you only have to do that once. So once you've created, it's allocated. Those pointers, originally null pointers, are actually accessible where you can use them later on and you won't have issues. The data type, or kind of what we're doing here, is we're actually printing it to a string value, a C string. So we are setting that value and then loading it up and redrawing the screen with the LV task handler. So that's happening. I put that in the handler where I'm getting the data from all the sensors. So it spits all the data, and then I'm updating those different areas on the screen as I get each particular value. So I get a humidity, update the humidity, iterate through all the results, and make sure that they're all updated on the screen. And then the LV task handler is called after all that looping is complete. So for that, this is an example of how you can update your screen. You update everything, and then you just redraw it once instead of redrawing it after every time. So again, completely up to your application. So I mean, I found it fairly easy. I created this sample, so there's a sample linked to the exact code that's displaying all that data in the description box below. It was fairly straightforward. I was able to find all the appropriate drivers and things that I wanted to get started. I was at first dubious that if it was going to work because it was using a different driver than what I found on Zephyr, but hey, it works, so I can't complain about that. So in general, LVGL, I haven't had any issues with. I'd like to see if I can kind of get more complicated samples working, maybe a color OLED or a color LCD. I think that might be interesting too, but just haven't gotten there yet. And of course, my thing is just my screen is just a binary OLED, so it's on or off. But it does work with all types of screens. Like if you go back and look at that website, I'm gonna go show it again. But that was if you go to their website, lvgl.io, that those screen examples there on the right side where it looks like a kind of a dashboard, that's what you can do in LVGL, which is pretty powerful, pretty cool. They're showing some examples of like widgets and kind of things you'd expect from a smartphone, but it's like you can put that on embedded, which is really, really neat. So let me get back here. That's the gist of it. If you guys want to see me kind of dive in a little bit more, maybe do something a little more complicated, of course you can check out you can let me know, leave a comment down below. And if you'd like to see that exact sample code, you can definitely check it out. It's in the description box below. So let me make sure that there aren't any questions. Doesn't look like it. No questions, comments, concerns. And yeah, if you haven't already subscribed over on my mailing list, jaredwolf.com, I do send out a couple emails once in a while where you can check it out. Or just be on the list. You'll be in the know whenever these live sessions happen. Sometimes they're random. Sometimes I have to push them off. Usually I try to make it on Tuesday, but today's Wednesday. Here we are. So anyway, let me see. Got a comment from JG. Eating displays. That's been actually on my list for a while now, is getting one of those guys working, because low power, besides a backlight, like if you don't need a backlight, those are great because you kind of set it and forget it kind of thing, which is really neat. So that's a great point, JG. That's awesome. Hello, how to use a custom font? Good question. I think that might be a topic for another episode. You can definitely check out, like I mentioned in that kconfig file, they have all the font options. but you might actually have to load a different font, either by statically linking to it or something similar. So if you guys want to see that, we can definitely do that. All right. Any other questions? Cool. I don't see anything else. Well, thanks for being here, guys. It's good. It's great to virtually see you here. I can see everybody in the live chat. It was just really neat. Again, if you have any suggestions, love to hear them. You can leave a comment down in the comment box, and I'll try to get back to you. Or if you have questions, I try to get it back to everybody that comments on these videos. So until next time, we'll see you around. Thanks for being here. See you again.